All right, 3.8. What we do in 3.8 is use matrices to solve systems of equations. So we're going to bring it all together. It seemed like we took a jump in the middle of the chapter from solving systems to using matrices, and that didn't seem like there's any connection. Here's the connection in 3.8. So the first thing that we need to know is something called the identity matrix. Okay. So the identity matrix, let's list some things about it. It's a square matrix. So for example, that's what a G means. It could be a 2 by 2, 3 by 3, 4 by 4, and so on. Any square matrix has the same rows as it does columns. It has ones in the diagonal. I'm going to assume that's how you spell diagonal. Diagonal. I'm a bad speller. One's the diagonal, zeros elsewhere. What does that mean? Okay, so we know what a square matrix is, but what's a square matrix that has ones in the diagonal and zeros elsewhere? Let's do a 3 by 3 matrix, the 3 by 3 identity. Ones in the diagonal, zeros elsewhere. Okay, the next property is one I'll show you before I actually write down. If I take this matrix and multiply it by another matrix that's possible to multiply, let's say we multiply it by 4, 5, 9, 7, negative 1, 2. Let's see what happens. Okay, we don't have to multiply it by another square matrix. It doesn't have to be the same. It just has to be possible to multiply. This is a 3 by 3, and this is a 3 by 2. We've done this enough times, we should know we can multiply them, and we'll get a 3 by 2 as a result. So a 3 by 2. Yeah, and there. All right, so let's see what happens when we multiply the identity matrix by another matrix. So the first column, or the first row, first column, we're going to take the first row multiplied by the first column. I'm going to take black and put these guys here. So we get 1 times 4, that's 4, plus 0 times 9 plus 0 times negative 1, that's just a couple zeros. Alright, first row, second column, first row times the second column. 1 times 5 will just give us 5, and then we get 0, and 0 again, so we're just left with 5. Alright, let's move on to the second row, first column. And so we'll take the second row and put it right here. 0 times 4 is 0, and 1 times 9, okay, that's a number that comes over. 0 times negative 1. Okay, we'll go second row, second column. 0 times 5 is 0. 1 times 7. Okay, so 7 comes over. 0 times 2, that's 0. Alright, very last one. Hang with me. Let's do purple, because it's just so pretty. 0, 0, 1. 0 times 5 is 0. 0 times 7 is 0. No. Let's go. I made a mistake there. Third row, first column. 0 times 4 is 0. 0 times 9 is 0. 1 times negative 1 is negative 1. 0 times 5, 0 times 7. 1 times 2 is 2. So look what happened. We just got the exact same thing back. It's like when we multiply by numbers, like 1 times 2 is 2, and 1 times 3 is 3, and all that kind of stuff. So that's the third property of an identity matrix, is that if you take the identity matrix, which is represented by I, okay, and you multiply it by a matrix, so that's what we did. I times A, what did we get? This one, what we called A. Okay. That should also happen when we do A times I. Because something we learned from multiplying matrices in the multiplying matrices together section was that when you change the order that you multiply matrices in, it will most often change the answer. But not true with the identity matrix. Whether we multiply it this way or that way, we'll get A back. Now, changing the order assumes that we can change the order, so it would assume that you're multiplying by another square matrix. Okay, so just be aware of that. But if you multiply the identity times a matrix, you get the matrix, the original matrix. And if they're square matrices, then you can just switch the order and it'll be the same thing. And we are going to be working with square matrices here in a bit. Alright, so let's change colors and move on to a related but different topic. Inverse matrices. Okay, inverse matrices and the identity matrix are related in a way that you will soon see. Okay, so sometimes a matrix can have an inverse. So the only matrices that have inverses are square. The only matrix that can have an inverse is a square matrix. Because one thing that you're able to do with a matrix and its inverse is flip the order that you multiply them, and they need to give you the same answer. And that is it. The next one is one that I'll show you. All right. Let's take this matrix. 2, -7, -1, and 4. Okay, and then just out of nowhere, let's multiply it by this matrix. 4, 7, 1, 2. Let's see what we get. Okay, we are going to get a 2 by 2 matrix. Done this enough times, we know why that is. We're going to do 2 times 4 is 8. And we'll do -7 times 1 is -7. So we move over here. 2 times 7 is 14. -7 times 2 is -14. -1 times 4 is -4. 4 times 1 is 4. So we're going to add 4 to that. -1 times 7 is -7. And 4 times 2 is 8, so we add 8. And what happens here? 8 minus 7 is 1. 14 minus 14 is 0. -4 plus 4 is 0. And -7 plus 8 is 1. Look at that. We took two square matrices, two 2 by 2 matrices, multiplied them together, and got the 2 by 2 identity matrix. Right? It's a square. This guy right here is a square matrix that has 1s in the diagonal and 0s elsewhere. And then it has this property. So if we were to multiply this by another matrix, it would just give us that other matrix. So we multiplied this by this matrix by this other matrix, and got the identity. So if we call this A, since we were able to multiply it by this and get the identity matrix, we call this A inverse. So if you have a matrix and its inverse, you should be able to multiply them together and get the identity. You should be able to also multiply them in the reverse order, where A inverse comes first, and also get the identity. And if we were to multiply these together in the other order, we would quickly find that we indeed get the identity matrix, the 2 by 2 identity matrix. Last thing is being able to write a system as a matrix equation. Okay, that's what we're going to do. And to show you what I'm talking about, I'll just give you a couple of examples. Just made up examples here. I'm just making this up. Alright, so here is a system of equations. Shouldn't be a big shock to you. You've seen those before. I'm going to write this as a matrix equation. I'm going to use matrices to rewrite this information. So what I have here in this matrix is called the coefficient matrix. It comes from the coefficients in this system. So that's it's 2, -4, -3, 2. They go right there. Next, I'm going to multiply it by this matrix, x, y, vertical like that. And then it's going to be equal, this is the matrix variables, and it'll be equal to the matrix of constants, because we have these constants on the other side. Alright, so, believe it or not, this equation is the same as these two equations. It conveys the exact same information. It has the same relationships, or it implies the same relationships between x and y and 3 and 7 and all these other numbers. Right? You know, what I mean by that is, if we were to multiply these two matrices, let's see what we would get. So let's multiply this matrix by this matrix, and I'm sorry for the sloppiness of this, but I'm just going to bring that over. When I multiply them again, we're going to bring them over here. So we will get 2, so first row times the first row times the first column, we'll get 2x minus 4y Okay, and we're done. There's only one column in this matrix, so that's the only entry we have. That is one entry, and it's the first row and the first column. Next, we'll do negative 3 times x plus 2 times y. And look at that. We multiplied them together, we got this, and this is equal to this matrix. And if two matrices are equal, it implies that they are the same dimensions. This is a 2 by 1, and this is a 2 by 1. And that each entry is identical. So this must be equal to 3. That's what this equation says. And this entry must be equal to 7. And that's what this equation says. So all we've done is take this information, write it in a matrix equation. It's identical. Okay. So let's do a slightly more complicated one. We'll do 3 equations. 3x minus 4y. Okay, so we're going to take this system and we are going to write it as a matrix equation. So you have the coefficient matrix, 3, negative 4, 8, 1, negative 1, 1, 14, negative 2, negative 3. Then we write our matrix of variables, that's x, y, and z. Whatever order they're in from left to right, x, y, z, they'll be in that order from top to bottom, x, y, z. If we're z, y, x, we write z, y, x. Y, x, z, y, x, z. Just like that. And our matrix of constants, 2, 3, and 12. Okay, and the same as we did over here, if we multiplied all that together, we would get the same system. We did all that. Okay, those 3 things, identity matrix, inverse matrix, and writing a system as a matrix equation, those are the things that you need to know. Okay, so we'll put it all together and do some sample problems in the next video.